Hi everybody, this is Miss Moran, and I am super excited for us to get started learning. And this is your first video lesson. As I said in our class introduction on Zoom, that I will not use videos for everything, but it is a way for certain lessons to kind of move faster for certain students, to do it a little bit asynchronous while we're still working together on these guidelines and parameters that we have. So this one is an algebra review. So some of the things that we're going to be discussing in this video, you know, and you don't even need so much of this review. So in that case, you may move forward through it rather quickly to get through the examples and to the notes so that you can go ahead and get started on the practice assignment on Math Excel. But remember, you get to pause when you need to. So that means if you got to go to the bathroom, just go ahead and pause. If you need to rewind, then go ahead and rewind the video. That works too. So we're going to go ahead and get started. If you want to title this anything, you can just go ahead and put it down that it is Unit 1, Lesson 1, and that we're doing a algebra review. And this is going to be 3 parts. So today you're going to get the first 2 parts, and then next week you'll get 1 more part. So you need to have your notebook and a graphing calculator ready to go. So this would be a great time to pause if you don't have those things. We're going to only use the graphing calculator minimally, and it's going to be a feature you're familiar with. We're just going to use the Y equals button. Now, alternatively, if you have another device and you'd like to watch your video on that device, a desktop computer, a laptop computer, your phone, another tablet in your house, if you happen to have another device available, you wanted to do that, you can, and then you can use Notability for your notes. I just named the note that this is the Algebra Review Part 1. And then you can also use on your iPad the Calculate 84 app if you don't have a graphing calculator yet. But I do encourage you to have a physical graphing calculator at some point soon, because then you'll be able to use all of the features that you will physically need to have in hand when you take any standardized test, including some college entrance tests. All right, so go ahead and you can start jotting this stuff down. If you want to pause and then resume to listen to what I have to say once you've got this copied, that's a great strategy. If you want to listen for a little while, pause, catch up with what I've written, it's up to you. I'm going to continue to talk with only brief pauses, but I don't want to insert pauses into a video. It'll just make it way too long. So what I would normally do in a class is look around the room and to see how everybody's doing, ask if there's questions. And those are kind of natural pauses. You need to create those pauses by actually pressing the pause button and stopping the video, and then jotting down where you might have a question and posting that to Schoology, or you resume it on Zoom. You can come back to Zoom and make sure I answer your questions there. So we're going to start with the vocabulary relation and function. A relation is the set of ordered pairs, x and y, and they could be like distance and time. Like it doesn't have to be x and y. I could have 2 different variables that one is dependent on the other. Like distance might be dependent on time. Over time, as time occurs, distance is greater or less. Whatever we're measuring. So ordered pairs, though, that's a relation. Now, a function is a relation that maps or pairs each input to exactly one output. Now, that's very important. And you may have heard from other teachers in the past for your math classes say x can't repeat. That's what a function is, when x doesn't repeat. Well, what does that really mean? What it means is that if I have an x value, and that x value is actually paired with more than one output. So the number 3 is paired with 4, and the number 3 is paired with 7. So if an input is paired with more than one different output, then it's not a function. What does that look like visually? Well, it looks like x is repeating. So a quick check is, does x repeat? But truthfully, we're going to the definition of function, and that is that each input is only matched with a unique output. So what name do we give to all the input values? We call the input values the set of all input values is the domain, and the set of all output values is range. So when I talk about domain and range, that's what I am speaking of. So go ahead and jot down any notes, pause if you need to, and I'm going to move on, but you can pause. That's the convenience of a video. All right, next up is 2 different types of notation. Now the first notation, set builder notation, is not actually super popular in classes before you get to college level, but I want you to be familiar because you're going to see it on Math Excel, and it's not a super complicated one. You may have already seen it. Set builder notation starts with these little squiggly fun brackets, and then we start with a variable, whatever variable we're speaking of, and we write X or Y or T for time maybe. And then I write a vertical bar, and that vertical bar actually is pronounced such that. And all that is saying is I'm giving some conditions to X. I'm putting some restrictions or limitations or a description on X. So we say X is our variable, such that X must be, and here's your restriction, greater than 2. So it starts with declaring the variable X, such that all of my X's must be greater than 2. That's it. That's the whole notation right there. And it's a very, grown up mathematical notation, if you will, very mature mathematical notation, and you will find it in much higher math classes in studies in college. Here's another example. Maybe I would say Y such that Y is, and this is a notation for element. It's a fancy looking little E. Element, meaning it's a member of a club, perhaps, maybe the real number set. So here we're saying that Y has to be a real number. It can't be an imaginary number. And that is what that notation means. Interval notation is one you're super familiar with. It takes any inequality such that, like, for example, X is greater than or equal to 4, okay? And it puts it, this is, by the way, not interval notation. This is inequality notation, but we're going to write it as 4 with a hard, solid, square bracket, those 3 words, solid, hard bracket, square bracket, those are the words we use, comma, infinity, soft bracket. Now you say, well, that's not a bracket, it's a parentheses. Well, I can use the word bracket if I also describe it as a soft bracket. So soft bracket and parentheses are interchangeable. Why do we use a hard bracket? Well, the hard bracket tells me that it is included. Okay, so that's included or inclusive. And then this parentheses is for exclusive. You say, well, why are we excluding infinity? We are not actually excluding it per se, but it is that infinity is not a place that can be reached. It can't be actually counted to. It's this idea that it is the largest conceptual number out there. So I can also use, for another example, -3 is less than X is less than or equal to 5. This is a between statement. It tells me that X is between -3 and 5. But what does that look like in interval notation? Well, I would use that soft bracket on -3, and I would use a hard bracket on a 5. Or I would say I would use a parenthesis on -3 and a square bracket on 5. So just the language, but it's exclusive of -3 and inclusive of 5. We will definitely be using interval notation frequently in this class as we describe graphs and conditions on X and Y. All right, so now we're going to hop to a couple examples. So the next few screens are just some examples of what you're going to see as you do some practice of this on Math Excel. The first one is saying, is this relation a function? And we just have to look at what's called the mapping of, or the pairing of the X's with the Y's, the domain values with the range values. And what I see here is that -2 matches with, or is paired with 7, 3 is paired with 3, 4 is paired with 3, and 9 is paired with 8. Now, we can look at this as like that idea of, do the X's repeat? And the X's actually don't repeat. Each X goes somewhere, and each X does not have 2 exits. So the number 2 is not, or -2, is not going to 2 different places. You say, wait a minute, but the 3 is receiving 2 different. Yes, that's okay, because the 3 is matched with a 3 and a 4 is matched with a 3. So the x's are all going to a place. That's great. All right, the next one. So let me conclude that. Yes, this relation is a function. The next one. These are written as ordered pairs. And we would look here and say, well, -2 is actually being partnered with two different numbers. So -2 is being paired with different y values, and that makes this not a function. So no, this relation is not a function. Okay, so next up is the domain and the range. So let me put a heading on here. Title my table. Again, pause if you need to write down the example. I am, again, not going to stop speaking. I'm going to go ahead and just to keep the video length short. It may take longer for you to watch the video than the length of the video, but that's the idea. Okay, so find the domain. In this case, my domain must be written as a set, just a set of numbers, a list of numbers with commas between them. I typically write them in numerical order. It's not necessary, but this is my domain. My domain is -3, 4, 5, and 7. You say, why isn't it -3 to all the way to 7? Like a between statement. And the reason it is not is because I don't know if there's numbers in between. Based on what they gave me, which is just this table, I only know about these 4 individual points. I literally know about 4 dots on a graph. I do not know if there's anything connecting those dots, okay? It's a very bad picture of this. So I'm also going to write down the range, even though it wasn't asked of me here. My range would be -1, 0, 1, and 8. And the reason I'm writing that is just so you can see. It's a list of numbers. I don't know if they are connected, so therefore I'm not using an inequality idea to say everything between these two spots. This one, however, they are connected. So we're going to call that -3 on our graph. We're going to call this height of +2. We're going to call this a +2, and we're going to call that a -1. So I'm just kind of giving myself the boundaries. Since my domain is the x values, my domain is going from -3, so I'm going to highlight that. My domain is going from -3 to +2. However, my domain is a soft bracket on -3 because of the open circle, and a hard bracket on +2 because of the closed circle. My range, that means I'm going to go this way on my graph. I'm going to go from the bottom of it to the top of it. So how tall does it span? And that one would say, well, it goes from -1 at the bottom and +2 exclusive at the top. And that's because of this open circle that we use the exclusive brackets. So recap on that one. Domain goes from left to right, and range goes from bottom to top. Alrighty. Well, if I'm not providing you with a list of ordered pairs, or I'm not providing you with a graph, but you're actually getting a function defined as an equation, and I ask you to find the domain, the way we would do this is we would look and say, well, what is x not allowed to be? What is the restriction? We say, well, it's a square root. And for square roots, we can't have negative numbers under there. Well, negative numbers mean that we must be greater than or equal to 0. So that's what we're going to do. If I want, I made a 0 for me, or a circle. If I want to be greater than or equal to 0, because that implies not negative. Okay, well, I should write not up here. Not negative. Then I'm going to set this up to provide me with what I want, to not be negative. So that means I want x to be greater than or equal to -4. In interval notation, it looks like this. So that is my domain. If I put in a -4, I get a 0. The square root of 0 is perfectly acceptable. But if I put in something smaller than -4, like -5 or -100, I get a negative number underneath the radical, which would not be permitted. Okay, now we look at a fraction. Fractions have limitations when the denominator equals 0. In other words, we don't want the denominator cannot equal 0. So let's set this up to figure out what makes the denominator equal 0, since we don't want that. Well, then x cannot equal 2. So in order to write that in interval notation, I would say, well, x is allowed to be negative infinity and everything up to 2, but not including 2. And x can be everything greater than 2, but not including 2. So this right here, this symbol is a union, and that union symbol is saying everything in this set on the left and everything in this set on the right combined together. And because we're using 2 in both of them, we're just kind of skipping 2. Like this idea here says skip 2, skip the number 2. All right, last example, okay, and this is evaluating using a function notation. So I'm gonna be substituting in, and we just have to make sure that we are following our order of operations. That is that I am making sure I square this before I multiply it by 3. You can use a calculator as long as you're using the parentheses accurately. Your calculator will give you the correct result. So I'm going to square the -1 to get a positive 1. I'm going to multiply by 3, gives me a 3. Subtract 1 gives me 2. Let's try this with f of 3. So 3 squared is 9. 9 times 3 is 27. 27 minus 1 is 26. This one says I need to substitute in an expression for x. So I'm replacing x with m plus 1. So that'd be 3 parentheses m plus 1 squared minus 1. I need to actually square that quantity. So that would be m squared plus 2m plus 1 minus 1. Distribute 3m squared plus 6m plus 3 minus 1. And finally, 3m squared plus 6m plus 2. And that is me evaluating that one. Go back and listen to it again. Pause it if you need to. That is our last example. So your practice assignment to go along with this is in Math Excel, and it is titled Unit 1, Lesson 1, Algebra Review 1. So your math assignment in Math Excel will always match the name of the video or whatever I call our live lesson. I'm going to keep the name of the lesson, video or live, to be the same as our Math Excel assignment, so you can correlate those pretty easy in your notes. I would encourage you as you're working through the Math Excel is to keep your notebook open so you can just kind of write stuff down. That way if you have a question, you can articulate it better to me, or you can send me a picture or show me and share your screen on Zoom with me, so that I can actually help you with the work that you're doing and not just what you recall from the screen. So use your notebook, use a pencil, or use Notability if you're using another device. Thank you guys, and please make sure you let me know if there's anything else I can do to help you through this. I want to be there for you at all times. And thanks a lot, you guys.